In this video, I will cover two addition reactions of alkenes, which are the epoxidation reaction, and the next one will be the ozonolysis reaction. In the epoxidation reaction, we use a reagent which is called a peroxy acid. So this is a peroxy acid, and it's a peroxy acid because it has those two oxygen groups. This is a peroxy group, and it's an acid because it looks like a carboxylic acid. And using a peroxy acid with alkenes leads to the formation of epoxides. Epoxides are compounds that have two carbons which are both bonded to the same oxygen. So this is basically what we call the epoxy group or the epoxide. It's a very simple reaction. You just have to add oxygen to the two double bonded carbons. So for example, let's say in this case here, I will just draw my compound without a double bond. The double bond was between this carbon here and this carbon here, so I will just put an oxygen in between and connect it to those two carbons, and this is it. This is how we draw the structure of the product. Again, whether it's a cycle or an acyclic compound, the same thing. My double bond was between these two carbons, so I'm gonna put an oxygen here, and then oxygen will be added to those two carbons here. MCPBA is also another type of peroxy acids, metachloroperoxybenzoic acid, but again it does the same thing, which is just adding an epoxide. So oxygen, it could be from the top side, so I can put an oxygen here or I could put an oxygen here. So this is oxygen again added to those two carbons. This is the epoxide. This is the last example. Again, this is the most accessible phase, so that's why oxygen will be on this side. Definitely the oxygen will be added from the same side. So if I have to show the stereochemistry, those should be both wedges or both dashes. So this is like both wedges or both dashes in all the cases. This is the epoxidation reaction. Finally, we'll talk about the ozonolysis reaction. Unlike all other previous addition reactions, which usually just added two groups to those carbons here, this reaction adds two groups, but later on it causes what we call cleavage of the carbon-carbon double bond. So upon ozonolysis, the carbon-carbon double bond will be broken, and we will get different fragments that have, as you can see here, the carbonyl group. First of all, how do we draw the structure of the product? Simply what you have to do is that you have to cleave, you have to break this bond, and then give an oxygen to this carbon here and an oxygen to this carbon here. So for example, what I would do is the following. Let's say this is my alkene. So if I want to draw, let's say, the ozonolysis reaction, what I would do is the following. I would just erase the double bond or in between the double bond, and then I have two separate fragments now. I will just add double bond O to this fragment and double bond O to this fragment, and that's it. This is how we end up with getting the two fragments. So let's try to solve this example here. So I'm going to cleave this bond. That's why I'm starting from the left side. So my double bond was here. I'll just put double bond O plus another oxygen. That's it. Okay, so again, cleave here, which means that this is going to be the first compound plus the second compound. One more example here. This is O plus, so you just usually start from, so it's up to you. You can either do this, or you can just say, for example, this is a double bonded carbon, this is a double bonded carbon. Okay, so I will start drawing the structure from the left side, from here. And once I reach to that point, I will stop and add double bond O. And then I will start redrawing the structure from the right side. And again, once I reach to that point, which is in this case here, I will just add a double bond. So this is how you end up drawing the structure of the different fragments. If you have more than one double bond, then you have to cleave them all at the same time. That's why I'm gonna cleave here and here. So if we apply the last method, I will have 1 point here, 1 point here, 1 point here, 1 point here. So starting from the left side, those are the two carbons. This is a point, so add double bond O. This is the first fragment done. Then starting from this point here, so I have a branch. This is a point, so I will add double bond O. And now we have another point here, which is this carbon. I will add another double bond O. And then finally, if I'm drawing this fragment here, we'll just put here. So this is the dotted, the highlighted carbon. So we'll just put double bond O. So we get basically 3 fragments, and one of them has 2 carbonyls. This C double bond O group is called the carbonyl group. So it has C double bond 2 carbonyl groups. Even in cycles, you have to do the same thing. So I'm gonna cut this bond here. Those are my 2 double bonded carbons. You just have to be careful how to draw the structure. So at this point, I'm gonna add double bond O. Then I will just continue drawing the structure. So this point is this point now. I have to add double bond O. You can add it in any direction. You don't have to put it like in this direction. You can just put a double bond O, let's say here. Okay, and then just don't forget to add this carbon, so you can add it up. So directions don't really, the direction of the carbon doesn't really matter how you draw it. Since I have 2 double bonds here, I have to cut at this point and at this point at the same time. That's why in this case here, starting from the top side of the molecule, I have those 2 points which were originally double bonded, so they will get double bond O plus. And then I have this carbon here and this carbon here again. So starting from this point, I have a double bond O. Then I will just continue the structure, and at this point here, I have another double bond O. So basically, it's just cleaving the double bond and adding oxygens on both sides. And this is how we draw the structure of the products of an ozonolysis reaction.